Greetings and welcome to using the TI-84 Plus calculator. This is your presenter, Lynn Mann, and in this problem example, we'll be working with hypothesis testing. Let's work through a hypothesis test problem from top to bottom. So here's the problem we have. In a study of 420,019 cell phone users, 172 of the subjects developed brain cancer. We want to test the claim that a cell phone user develops brain cancer at a greater rate than that for a non-cell phone user. And we know the rate of brain cancer for non-cell phone users is 0.0340%. Now, since this is a very critical issue, we're dealing with people's health and possible of their lives, we want to use a very small significance level. We want to minimize the possibility of a type 1 error to a great extent. So we're going to use our significance level of 0.005, meaning our alpha is 0.005. Now let's set up our H0 and HA so we can at least see what we're talking about. And we're going to try and figure out in the process which tests we're going to use. Now, we've studied 3 different types of tests so far. We've dealt with z-test for mean, t-test for mean, and z-test for proportion. Now, the cool part about kind of listing those 3, nowhere in the problem description did we talk about averages or the mean. So 2 out of 3 tests are kind of ruled out because we're not dealing with means, we're dealing with this many cell phone users developed cancer out of this many, and therefore it's proportion. So we're going to be doing a proportion z-test. Now that we know what type of test we're going to use, let's set up H0 and HA. Test the claim that the cell phone users develop brain cancer at a greater rate than that of non-cell phone users. So we're going to test the proportion against the rate of the brain cancer for non-cell phone users, 0.0340%. Because it's greater than, our claim is an HA. So H0 is the proportion that is less than or equal to 0.00034, because we're changing a percent over to a decimal. And our claim, HA, is the proportion is greater than this 0.00034. All right, let's run our test. We're going to go over to Stat, Run Tests, and we're looking for the 1 prop z-test, so 1 proportion t-test. Number 5. Our proportion is going to be the 172 people that developed brain cancer out of the number of people who were in the study. 420,019 people. Our X value is the number of people that developed brain cancer, so 172. Our N, oh, that's not right. Let me change that P0 value. Our P0 value is what we're testing against, so 0.0034. Oop, and I missed 1 0 to boot. 34. Our X value is the 172. Our N value is 420,019. And our test that we're going to do is the HA of greater than. So let's change this to a greater than. And I'm going to go ahead and draw it. Why not? Let's see the result as well as have it calculate our result. Okay, great. So we have our solution not only drawn, but we do have our calculation as well. Our p-value is 0.0073. Comparing that to our alpha of 0.005, we can see that our p-value is greater than our alpha value. And if our p-value is greater than our alpha, then we can't reject H0. P is greater than alpha, we fail to reject H0. And because we failed to reject H0, that means H0 is good. meaning the proportion of people who are cell phone users who develop brain cancer versus all cell phone users is less than or equal to non-cell phone users. And therefore, we don't have enough evidence to support our claim that the proportion of people who use cell phone develop brain cancer higher than non-cell phone users. So we have to make meaning with this number. It's not enough to get the number. We have to translate that number into a result and a conclusion. So the conclusion would be there is not enough evidence to support the claim that cell phone users develop brain cancer at a greater rate than non-cell phone users. All right, that's it for this one. Until next time, be seeing you.